Alright, we're back with another algorithm video. The problem here is that we have two linked lists that represent numbers, and then each node of those linked lists have one digit of that number. The trick here is that we're using singly linked lists, so they can only go forwards. And then the other trick here is that the numbers are represented in backwards order. So the number 5,243 in the linked list would be 3, 4, 2, and 5. So we got to figure out how to add those two linked lists together and return the result. Alright, before we start looking at the actual pseudocode, let's talk about how we add as a human being. So what we do is each column we add the numbers. So here the first column is 9 plus 2, and that is 11. So we keep the remainder, which is 11 minus 10 is 1, and then we carry over 1. And then we move to the next column, so 3 plus 9 plus 1 is 13. 3 is the remainder, 13 minus 10 is 3. And then we carry over. We have nothing over here, so we just drop the 1. As a human, we can see that this 1 really means 100 because we have the context of these other two numbers. But a computer doesn't have that. It would recognize this number as 1, not 100. So we have to figure out a way to tell the computer this is 100, not 1. Alright, so here is the actual pseudocode. Notice how we have four main integer variables. We have a and b, those are going to be the nodes that we're adding together. And then we have a carry, which is basically just a flag if we're carrying or not. And an index, which tells us which digit place we're in, whether it be the 1s, the 10s, the 100s, whatever. The main part of the algorithm is that we're looping through each node of both linked lists at the same time, and then we're adding those nodes together and adding the carry to that and setting it to total each time. And then we're checking as our second step if that total is greater than 9, meaning we would have to carry. And if we don't, then we do this arithmetic, and we'll talk about this arithmetic when we look at the code. If the carry is if t is greater than 9, then we have to set that carry variable to 1. And if it's not, then we have to set it back to 0. For the third step, we simply increment the index and which node we're at in the linked list. And for the fourth step, it's basically independent of the loop. So we check if the carry is equal to 1. If it is, then we do arithmetic. Alright, so over here, let's look at an example. We have the number 62 plus 79 in our linked list. The numbers will be represented as 2 and 6 and 9 and 7. Alright, so in our algorithm here, we have step 1, add the two nodes a and b plus the carry. Notice how we set carry equal to 0. Initially, so carry is going to be 0 to start. Index is also set to 0 initially, and then we have a is set to the first node of the linked list 1 rather, so 2, and then we have the second linked list is 9, so that's going to be b. Alright, then we move to the second step. We have our total, which is 9, 2, and 0, so 11. 11 is greater than 9, so we have to set the carry equal to 1. Actually, we won't do that yet. We'll do add 10 to the power of index, which index is 0, so 10 to 0 is 1, times whatever the remainder is. 9 plus 2 plus 0 minus 10 is 1, so 1 times 1 is 1, so the total is now equal to 1. And then we set the carry equal to 1. And it's important that this instruction here comes after this arithmetic. Alright, and then we move to the next two nodes, which is 6 and 7. After we, of course, do step 3 here, which is increment the index. So we move the index to 1, and we're now working with 6 and 7. Alright, we do our step 1, 6 plus 7 plus 1 is, 14. 14 is greater than 9 again, so we do 10 to the index, so 10 to the first is 10, times whatever our remainder is, which is 4. So 10 times 4 is 40, so we add that to the total. So our total is now 40 plus 40, or rather 40 plus 1, so 41. And then we increment our index again and our nodes, but our nodes are done. We don't have more nodes. So index is now equal to 2, and we do step 4 because step 4 is independent of the loop. If our carry is equal to 1, which it is from our last iteration, then we're going to add 10 to the power of index. 10 to the second is 100, so we add 100. 100 plus 41 is 141. And if we do this calculation really quick, let me pull up the calculator. Alright, we have 62 plus 79. Oops. There we go. 141, and that's what we got. So this algorithm works pretty well. Here in our code, I'm using a linked list implementation. That's not important. I will leave the implementation at the GitHub page for this project or problem, so you can use that if you want. Notice how we have two integer variables in our main function. We have the size and total, so we allowed the user to pick how many digit places they want their numbers to have. And then we insert data into each linked list, and then we do the algorithm. Alright, so here for the code, let's take a look real quick. We set our total to 0, index to 0, and our carry bit to 0, and then A and B aren't initialized to anything. We set our current node equal to the front of each linked list, and then we loop through each node using this condition if temp1, which is linked to the first linked list, it doesn't matter which one you use, is not equal to null, then we do stuff with it. So A is equal to the node of linked list 1, and B is equal to the node of linked list B, or 2. And so that's our first step. And then we check whether we carry or not. If we carry, then we do that arithmetic that we discussed. You can check this out on your own. It'll be at the Git repository I'll create. And then we do other arithmetic if we don't have carry. And notice how we're setting the carry to 1 if we do have a carry, and then carry back to 0 if we don't have to carry. Alright, and then after all of this arithmetic, we increment the index and we move the node to the next node. And then this is our fourth step here. We check if C is equal to 1. In my case I did C is not equal to 0, same thing. And then we just do this arithmetic. And then we return the total, and up in our main we print that total. Alright, so we're going to execute this code. Here the code has compiled successfully. We're going to be using these two numbers. So the first linked list will have 3425. We need 4 digits, so 3. Let me make sure I get this right. 4, 2, and 5. And our second one is 6039. 6039. And our result is 14,549, and we got the right answer. Okay, so the algorithm works. Alright folks, that's going to wrap it up for this video. Here is the Git for this problem. I have the linked list implementation here and the actual driver function with the algorithm in it. Alright, so check it out. Try to do this on your own. Catch you later.